This is the second video in the series Completing the Square, but this time using just algebra. In video 1 you saw that something like x squared plus 6x can be pictured like this. Here's the x squared, here's the 6x, and this shape can be sliced into two equal rectangles and placed here and here. Then, in order to complete the square, you'll need to add in a small square in the corner. In this example, it's the square of 3, which is 9. This completes the square, and it is the square of x plus 3. I hope you found these pictures helpful and that some patterns are starting to emerge. Here are a few more examples of completing the square, but now using just algebra. First example, can you complete the square for x squared plus 8x? Well, what you might have already spotted from the pictures is that you complete the square by adding another square number. Because the x term is 8x, take half of the 8, which is 4, and the added square is 4 squared. So an extra 16 completes the square. You end up with the square of x plus 4. Second example, complete the square for x squared minus 14x. Because the x term is minus 14x, take half of the minus 14, that's minus 7, and the added square is minus 7 squared. So an extra 49 completes the square, and you end up with the square of x minus 7. Third example, complete the square for x squared plus 9x. Notice that this time the x coefficient is 9, which is an odd number, but that doesn't scare me. Because the x term is 9x, take half of the 9, that gives 4.5, and the added square is 4.5 squared. So an extra 20.25 or 20.25 completes the square, and you end up with the square of x plus 4.5 or x plus 4.5. Example 4, complete the square for 2x squared plus 16x. Notice that this time the coefficient of x squared is 2, which complicates things a bit. And the easiest solution is to take out 2 as a common factor. So this gives 2 open brackets x squared plus 8x. You can ignore the 2 for the moment and simply complete the square for what's inside the brackets. Because the x term is now 8x, take half of the 8, that's 4, and the added square inside the bracket is 4 squared or 16. And you end up with 2 times the square of x plus 4. But remember that everything is multiplied by this 2. So to complete the square of the whole expression, it's 2 lots of 16, so add 32. Here's the last example. Complete the square of x squared minus 10x plus 18. And the twist this time is that there is already a number term, that's this 18. So let's park the 18 for the moment and simply complete the square for the other two terms. Because the x term is minus 10x, take half of the minus 10, that gives minus 5, and the added square is minus 5 squared or 25. And that's the square of x minus 5. But remember that there was already a number term of 18, so to complete the square I need to add an extra 7. And the final square I end up with is the square of x minus 5. And that's it for how to complete the square using algebra. But why might you want to engage in this weird behaviour? Well, it turns out that completing the square is a neat trick for solving quadratic equations. And that's the theme of the third and final video.